Hello and welcome to fifth lecture in chapter 19 of our comprehensive course on AI, ML and DS. Now, in this lecture, we want to talk about, in this chapter we are talking about basic statistics, and in this lecture, we want to talk about coefficient of standard deviation. In previous lecture, we did this Chebyshev's theorem, and we saw one very interesting application in our daily life of that Chebyshev's theorem. So if you missed that, I would strongly advise to go through that. It is very important even from future point of view also. Now this coefficient of standard deviation, what is the meaning of that? So sometimes standard deviation alone gives a misleading idea, okay, and therefore what we do is we take a ratio of standard deviation divided by mean. That parameter is called coefficient of standard deviation. Now for example, let us take two data sets. One is this data set A, which has values 12, 13, 16, 18, 18 and 20, and another is this data set B, which have value 131, 125, 131, 144, 158, 168 and 193. Both have, that means total 6 data points, and it is suppose a simple unidirectional kind of data. Everything is on x-axis. I find the mean of these observations and I get that mean is 16.17, and I also find the mean of these 6 observations and I find that the mean is 153.17. okay, so this mean is very large. Now I find the standard deviation. How to find standard deviation? That you know, first you have to find variance. How to find variance? That each observation minus mean. So 12 minus these, 13 minus these, 16 minus these, 18 minus these, again 18 minus these, and 20 minus these, and then square that. So sigma xi minus x bar, this is x bar, or mu, sigma xi minus mu whole square. So sum of those squares. So that is numerator and divided by the number of observations minus 1, because we are talking about a sample. So then the number of observation minus 1 is here 5. So that means sigma xi minus x bar, if you find, now we have done that calculation several times, so we are not bothering to do it, but if you do it and find standard deviation, first variance you will obtain and then square root of variance, that will give me standard deviation. So here standard deviation comes out to be 2.85. In similar manner, I can also take here the standard deviation, and that means this, that is 125 minus 153.17, 131 minus 153.17, 144 minus 153.17, 158 minus 153.17, 168 minus 153.17, and 193 minus 153.17. This is the standard deviation for, this will be the sigma, and then square all those terms, and then that will give me, add them, so that will give me sigma xi minus x bar whole square, and divided by 5 and minus 1. That will give me variance. Find square root of that, then that will give me standard deviation. So this is the standard deviation of my observations, right? Now it looks that this data is having very less spread, and in absolute terms it is correct that this data is having less spread. So that means its graph would be thin and high, somewhat like we have seen somewhere earlier, 3 graphs we had plotted. Yeah, this one. So its graph would be like this brown or red colored graph, thin and high. On the other hand, it looks that the lower other data, that is this data, its dispersion or standard deviation is very high, 23. That means it is 10 times more than that, nearly. Okay, so that means that data would be spread somewhat like this green. It would be spread over a very long or wide region. Also, in this case, the means were same in this graph, but here the means are also widely different, very widely different. So mean of that thin and high graph is 16 only, while the mean of that wide and less in height, that kind of graph is 153. So that means if I want to plot them like this, then you will see that this thin and high graph is suppose here, then that thick and that is the lower one and high spread graph, green graph, would be somewhere on the much right side, because its mean is 153, while the mean of this is somewhat some 6 point or some like that kind of value, right? So that is the case of the data distribution. Now the question is, okay, fine, so this has more spread in its absolute terms, but is the difference so much that this is having 10 times spread compared to that, or which is the right way of comparing these two data distributions? Then there are many applications in which we don't even compare the standard deviations directly, but we find first ratio of standard deviation and mean for the first data set, and similarly same ratio for the second data set. So here if I find this ratio, that is 2.85 divided by 16.17, so that is, here I have already kept it and ready for you. So 2.85 divided by 16.17 here, and you can see that the ratio is 0.176 roughly. Okay, so and if you express that in percentage, then 17.6%. okay, that is called relative dispersion. Relative to what? Relative to mean in this case. Some books or there are certain applications in which we find instead the median and find the standard deviation and to median ratio. Okay, but that is called relative dispersion. Similarly, here if I find the relative dispersion, it is 23.09 divided by 153.17. Okay, so let us find that. Then in that case, you will see that 23.09 divided by 153.17 is equal to 0.15, and if you express it in percentage, then it is around 15%. So 15%. Now that is interesting. That means that if I find absolute deviation, then I would say that data set A has less deviation. But with respect to mean, if I find, then actually data set A has higher deviation with respect to its mean, while data set B has higher deviation with respect to its mean. So in case of this kind of graph, that is where all means are coinciding, standard deviation alone is sufficient to compare two graphs. But as I said, in my case, mean of one was 6.57, while mean of other was 157 or something. So that green graph is actually here, and the red graph is still same position. Green graph is on far right side of the screen. Now, how will you compare them? So we will compare them by finding the ratio of standard deviation to the respective means. And to our surprise, we find that this is actually having less ratio. So relative dispersion is less. That parameter, that is the ratio of absolute standard deviation to mean, that is called relative standard deviation. Let us take this same data set and let us try to plot it. Okay. So here I am taking one NumPy array, and this is the same array, whatever I had taken here, 12, 13, 16, and so on. Okay. And similarly, I find its mean. I also find its standard deviation. NP dot standard deviation data A, and in NumPy you have to specify this DDOF equals to 0. Okay. This is written as population standard deviation. So maybe I think I should, if I specify DDO is equal to 1, then I will get sample standard deviation. Here it doesn't make any much difference because I just want to compare two values. Okay, and I can then find coefficient of variation, that is relative standard deviation. That would be this standard deviation divided by this mean. Okay, so that would be this thing. And same I can do for other data set. I create that data set also as NumPy array 125, 131, and so on. This is the same array 125, 131, and so on. I find its mean by NP dot mean. I find its standard deviation by NP dot standard deviation data B, and DD of equals to 0, degree of freedom equals to 0, and then I find the coefficient of variation B. Okay, so that would be standard deviation of B divided by mean of B. Okay, that ratio multiplied by 100, of course, because I want to find in percentage. Then I print out those things. So I just want to check that it is coming out to be same or not. So previous had mean of 16.17. So here you can see its mean is 16.1666. So that is 17. This had mean of 153.17. So this has mean of 153.1617. Okay. Then this had upper had data standard deviation 2.85. So here it has standard deviation 2.85. Lower had standard deviation 23. So lower had standard deviation 23. And the ratio of mean to standard deviation, that is printed at the here for the first data set. So that is third value here. So that ratio is 17%. Okay. So that ratio is 17%. And the ratio of mean to standard deviation, that ratio here is 15%. So here also you can see that that ratio is 15%. That is the coefficient of standard deviation. Okay. So there is no need of using calculator like that when you have NumPy or that text model library or SciPy. Then who needs a calculator? You should cultivate this kind of habit only. That whenever you want to calculate anything, just write a simple NumPy array in which you want to put the values of what you want to calculate and use the program only. That is how for your whole day you should go on doing things by code. Then coding should become second nature, and there should not be any requirement for doing any extra practice for that. Okay. Now let us plot these two graphs, because I said that one graph whose standard deviation is very small, that would be a thin and high graph, and this graph whose standard deviation is large, so that would be spread over a wider region. But I also said that in this case the means are at different locations. So that means mean of first and mean of second will not coincide. In fact, mean of this is much larger. So this thin and high graph would be somewhere, suppose here. Then that wide graph and shorter in height, that graph would be somewhere here, right, on the right side of the graph paper. So let us plot that and let us see what kind of graph is obtained. We also plot a KDE plot so that the data distribution is also seen. Now there is no need to bother about this code. Okay, let us discuss it. So here we are importing the library, Seaborn library and Matplotlib library, and then first standard steps are there thereafter, that plt.figure. If you remember, the standard steps are first decide figure, inside pass the tuple which is having the width of the data on x as x and height of the width of the diagram as x and height of the diagram as y. Okay, then so 10 pixels or 10 pixels or 6 by 6 pixels or maybe 10 centimeter by 6 centimeter, whatever is the default unit with Matplotlib, that will be the figure size. Once plot empty figure is created, then the next steps are very simple. Plt dot the type of the plot, or SNS dot type of the plot. So here I am drawing SNS dot KDE plot, because PLT Matplotlib does not have facility to put the KDE plot directly in one line of code. So we'll use SNS. Then we will use plt.x label, plt.title, plt.y label, and finally plt.show. So these are all those standard steps. Legend if you want to put, then plt.legend, plt.greed if you want to put, then plt.greed, and in parentheses you write true or false. So these are the same steps which we have been doing right from last many chapters. So here we are plotting the KDE plot for the first data set. I have already created my first data set, data A. So this is the KDE plot for that data set. We also draw one vertical line at the mean, just in case we want to compare the mean of the two data sets, and we want to find the how symmetrically or asymmetrically the data is distributed with respect to the corresponding mean. So this AXV line and then mean A color blue, line style this much, that will actually give mean. Similarly, this PLT.AXV line, V stands for vertical, axis, AX stands for axis. So the line would be like a vertical axis, but it would be where? It would be at the mean, because here this parameter says that here the line should start, and similarly this vertical line V axis will start at this point, mean. Okay, and these are the labels. So let us plot, and you can see this is the data set. This one, I am removing this output. This is this data set whose mean is 16 and standard deviation is very less, so it is thin and high data set. That is this blue. Okay, its mean is somewhere 16 and standard deviation is very less. Okay, on the other hand, the green one, that is this data set, mean is 157 and standard deviation is 23, so that is shorter in height and wider in spread. So mean is 153 vertical line and the standard deviation is this green line. Okay, so in that case you can see that these two data sets are far away from each other. Then how will you compare them? So that is the reason why we defined one new quantity, relative dispersion. So if I hurriedly give answer that this data set is more spread compared to this data set, but that comparison is when I want to compare two different data sets. But the question is compared to what? So then you have to see that if I compare each dispersion with its corresponding mean, then you will find that this data set is with respect to mean, its spread is 17.65, and with respect to this mean, its spread is 15%. Okay, so that is what you can get. Now, in this lecture as 18, okay, so understanding statistical distribution, fine. So this we will take in the next lecture. And now this is very important, and from here some interesting discussion will start. So stay tuned. We'll meet in next lecture. Thank you.